that is not at on one of the axes of the unit circle. Then it gets a little bit more difficult. For example, what if you want to find t equals pi over 4? Where t equals pi over 4, we have to figure out what the coordinate point is here. It's not 1, 0, it's not 0, 1, it's somewhere in between. We need to figure out an x value and a y value. Do you see that at the point pi over 4, it forms a right triangle? So really, to figure out the x and y coordinates of the point pi over 4, we need to figure out this distance, y, and this distance, x. And if we can find those two distances, we can figure out the coordinate pair for pi over 4. Now, one thing I'll have you notice is when you go from 0 to 90 degrees, halfway from 0 to 90 degrees is going to be 45 degrees, right? We also discovered that over here when we converted 45 degrees to radians, or we just converted pi over 4 radians to degrees, we got 45 degrees. So this is going to be a 45 degree angle. Do you remember those special triangles we talked about back in geometry? One of the triangles was the 45, 45, 90 triangle, where the side lengths were 1, 1, square root of 2. Well, we're going to be using a version of that triangle. But if you think about it, do you see that this triangle that we're going to be doing on the unit circle, instead of having a hypotenuse of square root of 2, it's going to have a hypotenuse of 1 because the radius of the unit circle is 1. For that reason, we have to adjust our special triangle here. Since the radius is 1 and this hypotenuse has to be 1, we have to take the square root of 2 and divide it by square root of 2 to make it equal 1. Since we do that to the hypotenuse, we also have to do that to both sides. And in doing that, our triangle side lengths change a little bit. So when we convert this triangle or simplify this triangle, we get side lengths of hypotenuse is 1, and the two sides are root 2 over 2. So what we're going to do, anytime we have a 45 degree angle, we can use this special triangle, this special 45 degree triangle, 45, 45, 90 degree triangle. If we take that triangle and place it on our unit circle, these become our side lengths, root 2 over 2 and root 2 over 2. So pi over 4 is going to be located at the ordered pair root 2 over 2, comma, root 2 over 2. So that would be our answer for t equals pi over 4. Be root 2 over 2, comma, root 2 over 2. Okay, so now, what if you're given a t equals 3 pi over 4? Let's see what's going on there. At 3 pi over 4, that's in quadrant 2. So again, let's see if we can make a triangle. This is going to be called a reference triangle. Do you see that 3 pi over 4 also makes a triangle? And all we really care about is the angle from 3 pi over 4 to 180 degrees, or 2 pi. So we need to figure out what is pi minus 3 pi over 4. Pi minus 3 pi over 4 is 4 pi over 4 minus 3 pi over 4 is pi over 4. So this reference angle is pi over 4, also known as 45 degrees. So now, do you see we can take this special right triangle here and place this here, negative x, positive y. So again, when we put this special right triangle on our unit circle, our negative x becomes negative root 2 over 2. Our y becomes root 2 over 2. So now we've used a reference angle to find the terminal point of 3 pi over 4, which would be negative root 2 over 2, because again we're in the negative x quadrant, and positive root 2 over 2 because we're in the positive y quadrant. So our answer to 3 pi over 4 would be negative root 2 over 2, comma, root 2 over 2. Okay, so what happens Okay, now what we're going to look at is what happens with another common angle that we're going to work with a lot, which is pi over 6. You'll notice that if we rotate around the unit circle pi over 6, that's 1/6 of pi times, you're not going to make it very far around the unit circle. You're going to stop pretty close to 0 to get pi over 6. Okay, then we'll have our pi over 4 that we already talked about. Then, if you think about it, we're going to look for 2 pi over 6. 2 pi over 6 is pi over 3, which is again less than pi over 2, so that's also going to be in the unit circle. So we have pi over 3. So we've got 1 pi over 6. We've got 2 pi over 6. Now, pi over 2 here is 3 pi over 6, which is pi over 2. So now we need to find 4 pi over 6. 4 pi over 6 is the same thing as 2 pi over 3. That's going to be in the in quadrant 2 because that is greater than pi over 2. Then we need 5 pi over 6, which is also less than pi. Then we move to pi, which is 6 pi over 6. Then we go to 7 pi over 6, which again is not reducible. 8 pi over 6. 8 pi over 6 reduces to 4 pi over 3. Then we've got 9 pi over 6. 9 pi over 6 reduces to 3 pi over 2, which sounds familiar. That's what this is. Then we've got 10 pi over 6, which reduces to 5 pi over 3, and 11 pi over 6. Then you get back around to 0, or 12 pi over 6, which reduces to 2 pi. So do you see we can break this unit circle up into sixths? And let's convert pi over 6 to degrees. Figure out how many degrees that is. Pi over 6 radians. We compare pi radians is the same thing as 180 degrees. So we cancel radians, we cancel pi, we get 180 over 6 degrees, which is 30 degrees. So pi over 6, this ever important right angle here, is going to be a 30-degree angle. And hopefully you remember that there was also a special right triangle called a 30, 60, 90 right triangle. That right triangle was 1, 2, square root of 3. But again, same idea. Do you see that the hypotenuse of our 30-degree angle has to be 1 because the radius of the unit circle is 1? So, with that being said, we have to divide everything by 2 in this case to get the hypotenuse to be 1. So when we divide everything by 2, if we redraw our special triangle here, the special triangle that we are going to use with trigonometry is going to be 1, 1/2, and root 3 over 2. So with that being said, let's try to